OR is basically used to turn on a bit. So this is what we called setting a bit. So we know how we can clear a bit with the help of AND operator. The same way we can set a bit with the help of OR operator. Now, if you want to toggle a bit, toggle, we can say flip a bit. If it is 0, I want to make that bit 1. If it is 1, I want to make it 0. For toggling, we use XOR operator. Okay. Now, let me show you how we can use XOR operator in order to flip a bit. So this is curing a bit. This is what we called set a bit. This is the clear bit operation. Third one is to toggle a bit. Or we can say the invert a bit, or we can say flip a bit. Flip a bit. PIT. Okay, so I just want to flip. Let me take 8. So this is 8. Fine. So now I just want to flip this bit. Remove this one for now. It is 8 actually. Fine. Now I just want to flip this bit. I want to make this 1 to 0. I want to turn off this bit, flip this bit. To flip, we have to write like now XOR equal to 1 left shift. I want to flip the bit number 3. So flip bit number 3. Okay. So this is bit number 0, 1, 2, and bit number 3. So I want to flip bit number 3. So what I'm doing, first of all, I'm performing a left shift 3 of 1. Then I'm just performing XOR operation. And we know that. Let me show you what is happening in the background. Let me print. Output will be 0 in this case. So this is okay. Check it out. This is 8. Okay. Now what I'm doing, this is 1. Now I want to flip this bit. So I have to take this one just beneath the bit I want to flip. So if I want to flip this bit, so I have to perform 1 left shift of 3. So 1 left shift of 3 will take 1 at this position. And then we are performing XOR operator. And we know that when both the value are 1, so the outcome will be 0 in case of XOR. So we are turning off this particular bit. Okay. After this operation, the bit will become output will be 0 in this case. So just a minute. We are flipping the very first bit. Yes, 0. Just let me put a slash n over here. Okay. Now I just want to turn that bit on. So I have to toggle it again. This is the outcome. Then what I'll do, I'll just perform XOR of 100 again. So this will perform a turn. Will turn on this bit as well. Okay. Perform bit. I have to perform repeat the same operation again. So what I'm doing, I'm just toggling a bit. First so here we are having 8, and we are toggling the bit, so the output will become 0. And again we are just toggling this bit again. The output will become 8 again. Zero, 8, 0, and 8. Fine. So this is the actual use of these operators. So and let me do one thing. I'll place it over here. Fine. So this XOR operator used to flip a bit or toggle a bit. If it is on, it will make it off. If it is off, it will make it on. Right? Set to turn on a closed bit. The bit is already on. This operation will not perform any, will not make any effect on your output. Right? If you want to turn off a bit, because a clear a bit, you can use ANDing. So this is ANDing operation. This is ORing operation. This is XORing operation. Okay. So there are a few more operations that you can perform with the help of this bit. We can check a bit just by performing a left and right shift. Okay, if you want to like pick a specific bit, you can just perform left and right shift to pick a specific bit. So these are the important like bitwise operator that help you a lot while solving bit masking, while solving problems through bit masking. So you can mask these bits with the help of these. So we have done with the operator part. So we have covered about all the operator. Now we know what is the behavior of operator, how we can just perform bitwise operations, or we can say bit masking operation with the help of bitwise operators. We know how to perform left shift and right shift of operators. And we have covered the logical operator and the comparison operator. Okay. So we have done with the operator part. Now it's time to move towards the next topic, which is actually the flow control. Right. So flow control is backbone of any programming language. So whenever we write a program, write a source code. So in most of the cases, the flow of our application is not linear sequential. Okay. If the flow is linear sequential, then we don't require the flow control. But there may be a situation where you are executing like multiple statement and you want to change the execution order of your statement. Right? So in that case, we have to use a flow control, right? Or we can say the control structure. Control structure of flow control is a way by which we can decide the uh, order of execution of a statement within a program. Right? So let's start with the flow control part. Control statements. Okay, so C language has a decision-making capabilities and support controlling of statement. C support following control and decision-making statement. So what we can do, we can just divide like uh, this statement in two different categories. Actually, there are three different categories in flow control. So we are having like a conditional statement, or we can say the selection statement. The second category is of loops, or we can say the iterative statement. And the third category belong to transfer statement. So just so mm, fine. So in C, we are having like three different category of statements that comes under flow control. Flow control, we can see the control structure. Okay, CTRL structure as CTRL. So we are having like a statement that are basically used for decision making. So we are having if and switch. In categories of iterative statement, or we can say loops or iterative statement. And we are having like a do while, publish like the transfer statement, or we can say jumping statement. So, so we're having like a break, continue. And you can also consider return as a transfer statement because it just perform jump from one function block to another function block. Just remove this for now. We'll discuss the return when we'll work with functions. Okay. Look at this. So this is the whole flow control part. Okay? So flow control help us to decide the execution order of a statement within a program. So we are having selection statement. In selection statement, we are having if and its various variations. Then if you want to repeat a set of statement for again and again for limited or unlimited number of time, then we are having loops for that purpose. If you want to perform jump outside a loop body, or if you want to move to the next iteration of your loop, so we can use break, continue, and go to. So first of all, we'll cover the selection statement part. Then I'll give an idea about loops, and finally how we can just use continue to perform jumping. Okay. So we are having like multiple variation of if. We are having if else, if else, if else. Okay. And then nested if. The different variations. So if when you are interested in true part only, then if when you are interested in false part, then if else, and there are multiple conditions and you want to evaluate only one out of them, else if ladder. Okay, when a condition depend on another condition, then nested if, and when there are multiple conditions and you are interested in all the conditions, then we can also have multiple if. Just just a way to make decision in your application. Okay. If else if ladder, nested if, and multiple if. Now, if your output depend on a set of a constant, set of integer literal or the character literal, so you can use switch for that purpose. The readability of switch is better than that of else if ladder. You can in many cases you can use a switch instead of else if ladder. Okay. Yes. Not all the cases. In some of the cases where the output depend on a group of character constant or the integer constants. Okay. And then you can use switch for that. Let me show you a small example. Suppose I'm having two numbers. Percent. Let me create simple logic. Num1, num2. Left enter two nums. I'm using scanf number, so format specify for each number and percent of. Right. I'm just expecting two numeric value from user, and I just want to perform division of the number. Okay, I want to perform summation of the number, so you can just try it. Printf is equal to percentage t num1 plus num2. Check it out. First number is a child. Please check it out. Output is 25. So please check it out. The evaluation order of this particular program is linear sequential. So whenever we run this application, so all the statement in this program will always execute. Okay. But suppose I just want to execute these two statements on behalf of some condition. Suppose I just want to perform summation only when both the number are even. What I have to do? Now we have to include some branching statement. Fine. So I want to perform summation only when both the number are even. So what we have to do? We have to introduce if. Right? Now this statement will not evaluate all the time. So now this we want to evaluate the statement on behalf of some condition. What I have to do? I have to include a branching statement over here. If, and here we have to write if num1 mod 2 is equal to 0 and num2 mod 2 is equal to 0. Okay, so I just want to evaluate this expression only when both the number are even. And so this is how we are like including a branch in our code. So if I run this code again, and if I pass, look at it, the first number is even, the second one is odd. Right? So what will happen in this case? The first condition is true, the second one is false. So what will happen? And we are using AND operation, the outcome will be false. So the statement will not be evaluated. Right? So we are getting nothing. So look at this. So I'm interested in true part only. That's why I've included only if statement. Are we getting output? Okay. Now suppose if a user pass odd value, we are we're not able to display a message on the screen. Suppose I just want to display a message on the screen that only even numbers are allowed. So what do we have to do? We have to include. We are interested in false part as well. So we have to use else. If you're interested in true part, you can use a if. If you're interested in both true and false part, you can use else. And if. Then we have to specify only when nums are allowed. Here, what we are doing, we are including a branch in our code. So if we pass 12 and 13, look at this. Only even numbers are allowed. So we are interested in true and false part, both. That's why we are using this approach. Okay, now this is how we can create branches in C. Okay, so if you just want to may take any decision, you always have to use if. If you're interested in true part only, use if. If you're interested in true and false part, both, use if else. If there are multiple conditions and you want to evaluate only one out of them, you can use else if later. Let me just show you a small example. So suppose enter your percentage. Okay, I just want to display a grid message on behalf of percentage. So what I'm doing, I'm just taking percentage as input. Please check it out. So what I'm doing, I'm just using else if later. If percentage, okay, is less than equal to 100 and percentage is greater than equal to 90. Okay, so I want to display message A grade. So what we are doing, we are just creating boundaries. If the percentage lies between 100 and 90, okay, then we have to display grade A. Else if the grade is not in this range, then we have to create another category. If percentage is less than 90, okay, and percentage is greater than equal to 80. So you can just simplify this statement as well. So what we can do, we can just skip this particular statement. We can just study percentage is greater than equal to 80. Okay, so you can just skip this statement as well if you want. But for the sake of clarity, what I'm doing, I'm just creating this range in this way. Def. Okay. Else. Def. Else is always we can say optional. Right? So if you want, you can include else. else is always optional. Okay, so please check it out here. What I'm doing, I'm showing this code. Now, if my percentage is 95, okay, so this is A. If I run it again, so that is 95. So it is B. Look at this. Okay, so else if ladder, uh, if the first expression evaluated true, the first condition is evaluated true, then it will check the next expression in the sequence. Okay, if the first expression is evaluated true, then it will not check the next condition in the sequence. Okay, the next condition is only checked if the first condition is evaluated false. Fine. Okay, so here look at this. This condition, so your expression, this expression will only be checked if the previous one is returning a false. So this type of logic is basically used when there are multiple conditions and we want please take
మీకు లేనా ఈ కవర్ లేనా నీకు
so here we are having multiple conditions and we want to evaluate only one out of them. Fine. Now if I'll mention like 13, okay, if I'll put a value like outside the limit 100, it's grade A. Let me run it one more time. If I'll mention 101, okay, no grade. It's working perfectly. So this is all we can use as a ladder. Now let me show you one important point. Okay. For you, what expression is considered as true in C and what expression is considered as false? What I'm doing, I'm just putting some values like numerical 12. Okay. Please check it out. Fine. So I'm showing you what values are considered as true in C and what are false. So if you pass any value, okay, other than a 0, null, and /0, all the value are considered as true. Look at this. I'm passing a numeric value. The output will be inside if. Okay. If I'll pass any negative value, please check it out. Okay, inside if I'll pass any character sequence. So character are entirely numeric. So this expression will be evaluated as numeric value 65. As you all know that the ASCII of capital is 65. Okay, but if I'll put a value like 0, okay, 0 is false in C, so the control will jump to the else section. Look at this. Fine. If we are having like null, the value of null is actually 0. It's a built-in constant with values. Look at this else. And if I'll pass a character sequence, it's slash, the ASCII of /0 actually. So these three values that are considered as false in C and rest of the values are considered as true. If I specify a name like James, look at this. Okay, so this is not 0, not null, not /0, so the output will be true in this case. Fine. That's the number one thing. Let me show you one more thing. Suppose I'm having a function like int test. I'm returning 0. And I'll call this function at this particular point. Please check it out what we are doing. We are calling this function inside if. So when we call this function, so the context switching will occur, control jump to the body of test, then test returns 0 to its calling environment, and this function will return 0. Fine. Can you please guess the output in this case? Please take care of mics. Yeah, just a minute. Absolutely correct. Fine. So the output will be. So you can also put function call over here. Please check it out. Fine. And if I write like a is equal to 0. Okay, let me put a variable int I over here. This gives the output. That will work fine inside else. Fine. But if I write like a plus of I is equal to 10. What will the output in this case? Please check it out. Absolutely, we'll get an error. Okay, we'll get an issue. L value required. Okay, fine. So we cannot assign like a constant another constant value. That's why we are getting issue. Right? So just with such kind of operations, just a minute. Please take care of your mics. So this is all. This is the behavior of your if statement. Okay. Now let me show you one more thing. What I'm doing, I'm just putting a printf statement, and here I'm mentioning space hello world. Because the printf is a function, so we are calling a built-in function inside the body of if. Okay. Here's the output in this case. Do you know what is the return type of printf function? Percentage. It return the number of characters that this function have printed successfully on your console. Fine. The output will be hello world. Then it will return. So 5, 5, 10 to 12, 13. Okay, 13 is the numeric value. So the outcome of this particular function will be 13. So if you get 13 as a value and 30 is the positive value, so the control will pass inside the body of your if block. So the output will be hello world followed by inside if. Fine. So the behavior of if. Okay. And now I just remember one more thing. Let me show you one more statement. So look at this. What I'm doing, I'm just removing these pair of curly braces. Okay. This I'll just remove the pair of curly braces. Let me put a small statement over here. Okay. So still this if block will work. Okay. So if you are having only like a one statement which is not of a declarative type, the program will work. So curly braces are not mandatory in this case. Because if I run this code, still it is working. Output will be inside if. Fine. So curly braces are not mandatory if you are having only one statement, and the statement must not be of a declarative type. If the statement is of declarative type, then curly braces are mandatory. Okay, so look at this, both the statements are not of declarative type. So if I run this code, it will work. We don't require curly braces. Okay, but look at this. If I'll put a statement like this, and I is equal to what I'm doing, I'm just trying to print the value of I. Please check it out. percentage D and I. Okay. Look at this. So what we have done, let's remove this one for now. So I've created a local variable I inside the scope of if block. Okay, and this if doesn't have any curly braces. That's why we cannot use I anywhere else in our code. If I try to run this code, look at this, we'll get some issues. Fine. Getting my point. So what we are doing, this is the first issue. Why? Because look at this, we don't have any curly braces along with if. So and we are having a declarative type of statement inside the body of if, and this I is local. That's why we cannot utilize this I anywhere else in our code. Fine. So here, curly braces are mandatory. Okay. So now the curly braces. So what we have done, we have wrapped the statement inside the curly braces. Now we get issue at this particular point. Why? Because we cannot access like this in the variable in the scope and outside the block. Now the issue will change. But look at this here. Now this program will work. Right. So if there is only one statement inside the body of if and the statement is of type declarative, you must have to wrap that statement inside the curly braces. Okay, if you skip the curly braces, the program will not work. Look at this. Fine. But for all the other local variables, local expressions, if you look at this is not a declarative statement, it's a print statement, it will work. So here we don't need to apply the curly braces for the if block. Just remember this point, okay? The curly braces are only required if you are having a declarative statement in the if block. Okay, now just another. After if we are having like one more we are having like one more decision making statement that is switch. Let me explain it in PPT. If you want, you can just take a snapshot of these PPTs. The statement is a powerful decision making statement. The statement is used to control the flow, control execution of a statement. It is a two-way decision making statement which is used in conjunction with an expression. These are the variations. We are having simple if else, nested if statement, and else if ladder. Just a formal syntax of if, then we have to pass a test expression. If the outcome of expression is a non-zero value, non-null value, then the control will pass inside the body of if. And if the test expression return null /0 0, then the control pass to the statement after the body of if block. Okay. After that, general form of if else. If you're interested in both print false part, you have to use if else. Okay. When there are multiple conditions and you want to evaluate only one out of them, we can use else if ladder. In else if ladder, if the expression is true, then the control pass inside the body of if. If the expression is false, then please check the next expression in the sequence. Please check the next expression only if the previous expression are written false. Only one expression will be evaluated in case of else if ladder. While in nest if a condition like rely on any other condition, so we can use if inside a if. So nested if means if inside another if. Finally, switch. So switch case control statement is a multi-way decision maker that tests the value of an expression against a list of integer or character constant. Okay. So when a match is found, the statement associated with that constant are executed. Fine. If any of the cases not found, then control jump inside the body of default. The default is optional. If you want, you can include default in your code. So default is not mandatory. Let me show some small examples on a switch. Instead of example, I'll just show you some questions. Then that will just give you an idea uh, about the behavior of switch. Just give me a moment. So here I'm having a folder name DT. And, here definitely we'll have some code. Give me a moment. So please check it out. I'm having a text sequence here. We are having like I just copied these questions from a website just for the better understanding of the C code. Okay, please check it out. Look at this. Here we are having a switch, and switch always work on cases, right? Look at this. Here we are having case one, case two, case three. As remember one thing, switch always accept a variable of type integer. Okay. So character is also integer and enumerator is also integer in C. That's why you can pass a character variable, character type variable, or a enumerator or a numeric value inside switch. Okay. Float and booleans are not allowed. We don't have any boolean types, so float value are not allowed. Why? Because between two float values there are infinite values. Okay. Between two float value, we can have infinite values. That's why a floating point variable is not allowed in switch. Okay, so you can pass only integer, character, and enumerator to switch. And the next important thing in cases, these values must be a integer constant, a character constant, or a constant expression. Integer literal or character literal, or a we can say constant expression. That means variables are not allowed inside cases. Other than important, okay. Now there is one more important point. You cannot perform any kind of declaration inside the cases. Fine. And if you put a simple expression inside the body of switch, like if I write a, let me just remove the statement for now. If I write printf, printf, and I'm just writing hello world. Okay. Can you please guess the output in this case? Check it out. A simple expression, switch, check. Nothing. Okay. So look at this. You can put statement directly inside switch, but that expression will only evaluate if you put that statement inside a case. A statement without any case will not evaluate inside switch. Okay, look at this. If I'll like increment the value of like unknowing variable, like num is equal to 100. Fine. What I'm doing, I'm just writing plus of like num. And what I'm doing, I'm just printing the value. Printf like percentage t, comma, num. Okay. Please guess the output in this case. Look at this. So I have like place a statement inside the body of switch, but the statement is not inside any case. What the output? What will the output in this case? Still 100. Why? Because if you want to evaluate expression, you must have to put it inside a case. Look at the output will still be 100. Will not be evaluated. So this is a valid syntax, but this syntax has no effect. If you want the effect of this particular syntax, you must have to put inside a case. Okay. Now, one more important point. Let me create a case. Case check to 2. If I mention like 1 colon like hello. Oh, sorry. Printf. And then I'm using a break. Okay. So it will not put break, then control will move to the next case body. So break is optional. If you want, you can apply break. If you just want to quit outside the switch after evaluating a case sequence. If you just want to evaluate the next body of the next case, so you can just like avoid this break. 2 colon, if I'll mention, and I is equal to 100, and right printf yeah, value of I is equal to %3, and after that here I'll mention like I. This is another loophole. Let me put a break over here. The default is always optional. Wrong choice. Huh? If you want, you can like avoid break in default, but putting break is a good programming practice. It will increase the readability of your code. And let me remove this one for now. So now if I try to compile this code, look at the way I getting issue. Why? Because declaration is not allowed inside the case body. Okay, just remember this point as well. Fine. Now, please check it out. Def hello. Control V. Print of world. I'm just like removing this break. Okay. So look at this. Here we are having a fall through like situation. And at the runtime, what I'll do, I'll just pass 1 as input. So check, the value of check is 1. So 1 is compared with this particular case. And once the case is compared, control move inside the body of the case and just evaluate all the expression until we get a break or your switch is completed. Fine. So here the output will be hello, followed by word, and followed by choice. Fine. Now, if we'll put the default at the beginning of this code, it doesn't matter, break, always evaluate at the end of the switch. Okay, look at this. The output will be hello and world. Okay. Now, if I'll mention an invalid value, look at this. Now, this case will not match, this case will not match, control will move inside the body of default, and after entering default, we don't have any break, so the output will be wrong choice, followed by hello, and then the world. Okay. Now, you have to be careful, when you are working with different case values. So please check it out here. What I've done, I'm just using a character A. Okay, so you can store like a inside the integer as well. It doesn't matter. Now what I'm doing, I'm just creating some cases, like a case. The first case is A. Please check it out. Huh? Then I'm putting some statement. Result is equal to %C, comma, check. Or just like we can write A. Now I'm coding one. Please check it out. Case. What I'm doing, I'm just using 65. So we know that 65 is A is actually interpreted in form of 65. Okay. So here we are having like a duplicate case value. So we mention 65 over here. If I try to evaluate this code, definitely will get the issue because this A will interpret it as 65 internally. And look at this, we cannot have like two cases with the same values. Okay, so the output will be, look at this here, we are getting duplicate case value issue. So this is also an issue. Fine. So you have to be very careful while working with the case of different type, especially when you're dealing with the like a integer character constant in a same switch statement. Be careful while working with different types of values inside case. Okay. Now let me show you one more thing. A is equal to 65, and what I'm doing, I'm specifying like check over here. So check is like a variable, okay, and the value of variable like can be modified within a code. So it is also not allowed. Inside case, only integer constants, character constant, and constant expressions are allowed. Variables are not allowed, and expressions with variables are also not allowed. Fine. Look at this. If I got to run this code, we are getting this issue. That is, a case label does not reduce to integer constant. Okay. Now let me show you one more thing. If I write like a int constant, like a constant check, and its value is 10. Okay. Let me create like a check over here. Check over here. Okay. Or let me do one thing. Check is equal to 10. I'll create one more const like a var is equal to. That's what I'm doing. I'm specifying var. Okay. So can you please guess the output in this case? Please check it out. Yes, still will get issue. Still will get issue. Why? Because constant can also be modified in C with the help of pointers. So this is also not allowed. Okay, so you can modify constant with the help of pointers. So anything that can be modified by the program during the runtime is not allowed inside the case values. Okay, but in all upcoming languages, like in all the new languages like Java, it is allowed. Constant are allowed. Okay, but in C, in some version of compiler, it is not allowed because constant can also be modified with the help of a pointer in C. Okay. Now, just to take a look at a few questions and let's try to give the answers. Very simple switch questions. Okay. So, yeah. Okay. So, please check it out. Copy this one. And please check it out. We have already covered the operator. I'm just discussing a few questions with you all. Please check it out. And just remember the operator precedence in this case. Can you please tell me which operator is having the higher precedence over here? Plus or the shift operator? Which is a higher precedence? Plus or shift? Shift arithmetic operator have higher precedence. Okay, so first of all, this expression will be evaluated. The value of movie 2 plus movie. Can you please tell me what will the output of this particular expression? It is 3. That means movie left shift 3. Value of movie is 1. Left shift 3 will result into 8. Fine. Please check it out. Output will be raised in this case. Fine. Why? Look at this here. Plus is having the higher precedence. So this expression will convert into 3 at runtime. And the value of movie is 1. So 1 left shift 3 is actually 8. So the output will be raise. Getting the idea. do some more expressions. Okay, please check it out. There is one more question. And here we have used a pre-processed directory. So the value of L will be replaced. Okay. So if I'll please check it out. Please guess the output. Let me put some flash in over here. Just to increase the visibility of this code. Look at this here. We are having like two variable inside parentheses, and we are having a comma operator. And we know that the associative of comma is from left to right. Can you please tell me what will be the outcome of this particular expression? Let's check out the output. 10 and 1 into 20. What will the what this expression? What will the outcome of this particular expression? What switch will get after that evaluating this expression? And D, okay. And what will the output in this case? Absolutely good. Fine. Chances. Just a few more questions. Please check it out. Context, just natural. Access constraint is not allowed. We have already discussed in this code. Inverters, get rid of an inverter. Please check it out. One more important question. Not important. Get an idea. Evaluate the expression, will get your result. Try to evaluate these expressions, these cases. Look at this. Here we are having the constant expressions. Okay, the expression will be evaluated at a compile time itself. The constant expressions, the value of this expression will never change. That's why these are valid expressions inside case. Please check out the output. Try to evaluate this expression.
ఏంది
Python. Okay, here we'll get an error. Why? Duplicate base case values. Okay, so complement of 11 is minus 12. Minus 12 will become 12. Okay, and here 6 minus 3 is equal to 3, and 3 left shift 2 will return 12. So here we are having duplicate case values. Look at this. The outcome of this expression is also 12. This outcome of this expression is also 12. Fine. 12 and 12, that is duplicate case value. So, fine. This is the issue. So first of all, while solving expression, you have to think just like compiler. So when there is a code in front of you, first of all, you have to check all the syntaxes issue and the semantic issue. If your program is syntactically and semantically correct, then you have to like put your mind in solving the expressions. Okay. one more expression. Take a good one for you all. Okay, please check it out. Huh? Please remember the value of A as well. Check out the output. So we'll get an error. Why? Because declaration is not allowed inside switch. Please check it out. First of all, you have to think just like compiler. First of all, check all the syntax and semantic issues, and if the code is correct, then apply your mind in evaluating the expressions. Just one more question, right? Oh, good one. Please check it out. Please check it out. Here, look at this. We are having comparison operator. Let's do the comparison operators from left to right. Please check out the output. Please predict the output. The output will be 1 in this case. Okay. Fine. Please check it out. A is equal to B. What will be the outcome of this particular expression? 0. And 0 is equal to 0. This will evaluate to 0. 0 is equal to 0. Is this true or false? So what will get stored inside A? 1. Okay, switch 1. And look at this. This expression is not inside any case, so it will not be evaluated. And the purpose of size of operator is to return the size of a variable. Size of the variable. It will not evaluate any kind of operation. Fine. So here the value of A will not be incremented. Still, you'll get 1 as output. Fine. So the purpose of size of is to return the type, a size associated with the variable. It will not evaluate any expression inside it. Okay. Fine. So that's all for the day. So we have completed operator and some of the concept of flow control. Now we know how to work with if, else, and switch. Tomorrow we'll discuss flow control. Then we'll cover the concept of functions, and if we get time, we'll work with pointers. And maybe tomorrow there may be a slight change in the class timing. Okay, there may be, okay, it's not compulsory. You'll get the message in the group. If you'll not get any message, then the class timing will be the same. Okay. So thank you so much. That's all for the day. I will meet tomorrow at the same time. Take care.